Hi everyone! In today's video, I'll be covering Lab 2, which is the first of a 3-part lab series. If you haven't done so already, please watch and read the Jove article as it provides a lot of background information on the procedure that we don't have time to cover. In addition, please take a moment to read the information here as a review on the things you've gone over already about PDMS in lecture. Before you start your lab section, you'll be taking a visit to the prototyping room for a demo. The laser cutter is currently undergoing repairs, so instead you'll get to witness the CNC in action. Keep in mind the different technologies you have available to you in the prototyping room, as when you are performing your independent projects, you'll have the opportunity to use them if you so desire. Let's get back to the lab. But before we get to the procedure, I want to take a moment to set the context of the lab section. In this 3-part series, you will be creating a PDMS stamp that you will use to pattern fluorescent protein onto a glass surface. So at this point, you're probably thinking, oh, well, how are we going to do that? Well, in Lab 2, you will create a PDMS stamp. This PDMS stamp you will further treat in Lab 4 to prepare it for the stamping step. In Lab 3, you'll be making BSA and attaching to it a fluorescent molecule. The chemistry that you'll be using to accomplish this is something you've gone over in your organic chemistry series at UCLA, so if you haven't already, you might want to take a moment to review that. I believe Dr. Seidlitz will also be reviewing the relevant chemistries in lecture. So what you'll do then is you'll take this BSA, you'll physically adsorb it onto the stamp itself, and this process, remember as I mentioned before, is going to require a little surface treatment that if you watch the videos from above, you'll already have seen. So all in all, you can see how this 3-part series is designed to help you figure out one way to create this particular pattern. As a mental exercise, and let's just practice, try to think of different ways you could pattern a glass surface with fluorescent protein. But for now, we're going to move on to the procedure for Lab 2 itself. One thing I want to emphasize is how much of a pain PDMS is to handle and to clean. So please think of me and the other TAs when you're handling it, as we will be the ones cleaning it later. One of the reasons why PDMS is really difficult to work with is because it's really viscous. For that reason, we're having you use transfer pipettes to aliquot the solutions. Be patient when you're aliquoting, and move slowly when transferring the liquid. Otherwise, you'll make a mess, and neither you or I will be happy. Each group is going to need to fill 2 molds, so you'll both get an opportunity to work with PDMS. One thing I do want to remind you guys of, and you'll see this when you actually get to the lab section, is that the molds are pretty small, so you only need a few mils to fill it. All this should be emphasized by your TA as well. Your TA is also going to assist you in degassing and actually curing the PDMS, but you might want to pay attention during these steps, because if you want to work with PDMS in your independent project, you're going to need to know how to do these yourselves. So if you think you might want to, just pay special attention to when your TA is demonstrating the desiccation and where the oven is. Okay, so when you finish your PDMS portion of the lab, you're going to move on to using the fluorescent microscopes we have available in the teaching labs. The bead solution that is mentioned in the protocol here is actually the same bead solution that you made last session, so just use that for this lab. Your TA is going to demonstrate how to use the EVOS microscope on both fluorescent and transmitted light settings. Pay particular attention to the differences in imaging modalities, as it will be tested later in the course. The protocol your TA is using to demonstrate the microscope will be posted online at a later date so that you guys can review it before your lab practical. Your TA is also going to discuss some advantages and disadvantages to fluorescent microscopy. You're just going to want to pay attention to that part because, again, you might be tested. But just for fun, can you think of a fundamental aspect of microscopy which puts a hard cap on imaging resolution? You'll find out the answer to this question and workarounds that have been invented in lecture. But for now, that's everything I have. Please feel free to leave me a message with feedback on the videos or any questions you might have. See you guys later.